Hello and welcome back to the Science of Concrete Materials class. This is lecture number 19 of the class, and today we will start on the second module of the class, which is the mineral admixtures. This module will take I think will take 3 lectures to cover though. So the fact and the need that properties of concrete in both fresh and hardened states can be modified by adding certain materials to concrete mixtures has been responsible for the large growth of the concrete admixtures industry over the last 50 to 60 years. With hundreds of products are being marketed today. So in some countries, it is not uncommon that 70 to 80% of all concrete produced contains one or more admixtures. So the construction engineers should have some knowledge of the advantages and limitations of commonly used admixtures nowadays. This is very important because admixtures vary widely in composition, from surfactants. We will see what that means in a bit, and soluble salts to polymers and the insoluble minerals, which we covered previously, the mineral admixtures. Generally though, the admixtures are used in concrete to improve workability, accelerate or retard setting time, control strength development, and enhance the durability to frost action, thermal cracking, mitigate the alkali aggregate expansion, the sulfate attack, and the corrosion of the reinforcement. Okay, the important classes of concrete admixtures, their physical and chemical characteristics, mechanism of action, applications, the side effects will be described in this module of the class. So let's look at the definition of an admixture. The official definition of an admixture, as set out in ASTM C125, is that a material of other than water, aggregates, hydraulic cement, and fiber reinforcement that is used as an ingredient of concrete or mortar and is added to the batch immediately before or during its mixing. So this is the official definition of an admixture according to ASTM. All right. This definition encompasses a wide range of materials that are used in modern concrete technology and includes both the finely divided solids, which again, the mineral admixtures we covered previously during the discussions about the supplementary cementitious materials, and includes also the water-soluble compounds, which are the chemical admixtures. Okay. There are also other admixtures that are used to produce specialty concretes, such as polymer latexes and shrinkage compensating admixtures. Those will not be covered in this class, but they are mentioned here for reference for whoever wants to get more information about them. Again, this part of the class is devoted to water-soluble admixtures that are added as solutions, during mixing. Okay, so let's look at some more terminology just for clarity. So the audience may hear 2 other almost identical terms, addition and additive. The term additive belongs to an older terminology and used interchangeably with admixture. Okay, keep that in mind. An addition, according to ASTM C219, is a material that is interground or blended in limited amounts into hydraulic cement during manufacture, either as a processing addition to aid in the manufacture and handling of the cement, or as a functional addition to modify the properties of the finished product. A functional addition would be an admixture added by the manufacturer at the cement plant instead of the contractor at the job site or the operator at the ready-mix plant. So type 1A, Portland cement has an air entraining addition that should, behave identically to type 1 Portland cement, to which an air entraining admixture is added. Okay, so this is an example of an addition, functional addition. An example of a process and addition is a grinding aid, which should not, in theory, affect the behavior of the finished cement. If you remember during the talk about the manufacture of the cement, and we have, for example, we add grinding aids and that sort, okay? So let's look at the classifications of the admixtures we are dealing with. As I mentioned, there are basically a bewildering number of products marketed as admixtures, for concrete. Many of them based on proprietary formulations, commercial brand names. However, most can be assigned to one of three broad categories of admixtures. The first being the air entraining agents, according to ASTM C260, which are added primarily to improve the resistance of concrete to freezing and thawing. Okay. The second being the set controlling admixtures. Those are classified under ASTM C494, which are added to control setting or to induce early hardening. Okay, this is the second one. The third being the plasticizing admixtures. Again, those are classified according to ASTM C494 and C1017. They are water-soluble polymers designed to enhance workability by increasing slump, particularly in excess of 185 millimeter, or the flow in concrete according to ASTM C1017, or to reduce the water requirements for a desired workability. Basically, in this case, we reduce the water requirements or the water amount added. These are according to ASTM C494. There are also miscellaneous admixtures, which include all those not included in one of these three categories. And basically they are used in special applications, okay? Okay, so here I am just listing the ASTM 494 categories and their classifications or their designations. For example, we have the type A, which are water reducing admixtures, type B, retarding admixtures, type C, accelerating admixtures, type D, water reducing and retarding at the same time, type E, water reducing and accelerating at the same time. We have type F, which are basically the high range water reducing admixtures, or referred to otherwise super plasticizers. And again, further definition according to ASTM C17. We also have the type G, which are for high range water reducing and set retarding at the same time. Okay, so let's talk about the use of admixtures. The enormous variety of chemical admixtures is due in large measures to the fact that almost every property of concrete can be modified to some extent, as I will show in the table in the next slide, okay? So it is basic that the reasons for using admixtures during the production of concrete will be equally varied. Okay, an admixture should be used to improve concrete construction, whether, be it handling or consolidation of fresh concrete, or in the performance of the hardened concrete, or maybe in the cost of construction. It should be emphasized, though, and you remember that and keep that in mind, that an admixture is not a substitute for poor mixing or sloppy concrete practices. Okay? So, and the potential user should first ensure that desired result cannot be attained by improvements in these areas. So again, sound and methodical concrete practices should be followed. The admixture is used to enhance a certain property or make our life somewhat easier on the job site in handling and placing and finishing concrete. The admixture will not replace bad concrete mixes or sloppy, less than sound practices in the field. Okay? Keep that in mind. So this is the table I just talked about, which is basically the benefits we get from the chemical admixtures, what these admixtures can do for us. Okay, so we can enhance and improve workability to handle and place concrete, which goes a long way in making sure we, for example, get rid of segregation or honeycombing or voids in the placed members. So these, the admixture types used for this, the water-reducing admixtures, plasticizers, air entraining admixtures also improve workability. The set control admixtures, again, if we want to control setting and prevent concrete, for example, from hardening too quickly. For example, we have the retardant admixtures for that. If we require early or quick setting, we can use the accelerating admixtures, okay? Or basically we control the setting time, whether we want to extend it or we want to shorten it. Also, strength and durability are impacted, improved by the use of these admixtures. For example, for this, the water-reducing admixtures, the air entraining admixtures, and the water-reducing admixtures, according to C494. Okay, if you remember, for the air entraining admixtures, adding these controlled air bubbles into the concrete mix will help the concrete to resist frost action better. And in this case, we will end up with more durable concrete. The water-reducing admixtures, the fact that reducing the water content of a mix in of itself is an improvement. Because if you remember when we talked about the water-cement ratio, low water-cement ratio increases strength and also help durability because it reduces the capillary porosity, and we have seen in the previous lectures what that is, okay? So again, every property of the concrete, whether in the hardened or fresh or hardened state can be improved by the use of some type of an admixture, okay? But again, as I said, the use of admixture is not a substitute for sound concrete practices. Okay, so about the use of an admixture, certain precautions have to be taken into account. All engineers who work regularly with concrete, I'm sure they have their favorite stories to tell of admixtures preventing concrete from setting or causing some other unfortunate problem. I have my own stories to tell, but fortunately, we always did our due diligence before using any admixture in the production of commercial mixes. However, the problems that do occur often, arise due to the lack of understanding of how admixture interacts with concrete. So to avoid unnecessary surprises, the concrete engineer would, do well to take few simple precautions when considering the use of admixtures. For example, first, require that an admixture must conform to relevant ASTM specifications where applicable, or whatever the equivalent specifications being used. A reputable manufacturer should also be prepared to supply adequate technical data for its product. This should include, but not limited to, the following. First, the main effect of the admixture on concrete performance. Second, any additional influences that the admixture may have, whether being beneficial or detrimental, they should be stated. Third, the physical properties of the material should be listed clearly on the material data sheet. Fourth, the concentration of the active ingredient of that material should be clearly stated. Number 5, the presence of any potentially detrimental substances such as chlorides, sulfates, sulfides, nitrates, or ammonia, all that should be listed. Number 6, the pH of that admixture should be listed, because we know the pH of the mix, the pH of the placed concrete, has significant impact on other durability issues, as we will see later. Number 7, the potential occupational hazards for users. That's a big deal. The safety of those who handle and work with that admixture is of paramount importance. So the supplier should exactly list what are the occupational hazards. Number 8, the conditions for storage and recommended shelf life. And again, many stories about admixtures stored for an extended period of time, expiring after that. Of course, they cannot be used and should not be used, and that basically throwing money away. Also, the preparation of admixture and procedures for introducing it into the concrete mix, when and how to add it. Also, the recommended dosage under identified conditions, certain conditions, how. So the recommended maximum dosage and the effects of overdosing. Those are the key elements that the manufacturer of an admixture should furnish to the engineer or to the ready mix supplier in order for them to be aware of the limitations of such an admixture. The second thing is, you must follow the manufacturer's instructions regarding dosage. But you also have to make relevant tests to check that the desired effects are being obtained. There is no escape from that. So it is particularly important that these tests be run using job materials under job site conditions, because the precise effect of an admixture will depend on many factors, such as cement composition, aggregate characteristics, and impurities in the aggregates, mix proportions, presence of other admixtures, type and length of mixing, time of addition, concrete temperature, and environmental conditions. So, following the instructions of the manufacturer when using an admixture, and more important though, you must run tests. The tests must be run on materials identical or the same materials to be used on that particular job. Exactly, because any variation, any change will introduce a whole new set of variables. So be careful. You must replicate the same job conditions and use the same materials in order to predict the effect of that admixture exactly. Okay? Number 3, ensure that reliable procedures are established for accurate batching of the admixture. Again, this is particularly important for air entraining admixtures and all chemical admixtures. Where typical dosages may be well below 0.1% by weight of cement. So in such cases, overdoses can easily occur, and the effects of overdoses will be disastrous. Okay, so again, you don't want to end up overdosing a concrete mix. The concrete mix will not be fit for use. So you either, I hope not, end up placing non-compliant concrete, or equally bad, you are going to throw away money after finding out that the mix will not be fit for use. Number 4, the effects that the admixture may have on other concrete properties. Again, we said they have side effects. This should be taken into account, particularly if these effects may be unfavorable. And again, most side effects, sometimes some good side effects, can arise, but mostly side effects will be unfavorable. So some commercial admixture formulations contain materials that belong to different categories, and their effects, may change significantly at different temperatures. So again, knowing what the admixture is, what the side effects, and what are the conditions where it should be used, and how these side effects affect your concrete mix, all this should be known. So there is a lot. I mean, it's like I said, it's tempting to use these admixtures. Sometimes they perform magic, especially when it comes to workability and slump. But at the same time, they have side effects, and these side effects should be investigated by the specifying engineer, and also should be known to the construction engineer who will be on the site, knowing how and when, for example, to reject a concrete mix. Okay? So also, having said all that, I will mention a few more points that, the engineer should be aware of, basically about the specifications and analysis of the admixtures. As I said, although many new compounds are being developed constantly for use in concrete, admixtures often are derived from waste products, from other industries, as we will see later. As such, the process or the composition will be, complex mixture of compounds. So, various compounds could be put in one mix, in one admixture. And that also, present a set of challenges. So suppliers, blend them with other chemicals to mitigate undesired effects, due to the fact they are multi-components, so the suppliers blend them with other chemicals to mitigate undesired side effects and to ensure uniform quality. So again, most admixture formulations are multi-component mixtures, and that could be good and bad at the same time. Good, that means we get a benefit from using them, the side effects being mitigated, but at the same time, undesirable side effects still may exist. So the admixture specifications, based on this fact that the chemistry of these admixtures are really complex, and you cannot really set certain values and figures in stone. So based on that, the admixture specifications are performance specifications, and basically what that means, it sets minimum changes in the property of interest. For example, the decrease in setting time, and limits on how the other properties should change, for example, strength. And again, it sets limits but no set figures. For example, the air entraining admixtures should conform to ASTM C260, which is essentially a performance specification in which the admixture is tested according to the provisions of the ASTM C233. Now, how to know the result or the effect of this admixture is fit for purpose? There is a key test in this method, is the performance of concrete exposed to rapid freezing and thawing according to ASTM C666. So again, these are performance specifications of if the admixture meet these specifications set, for example, in this case today, STM provisions, then it is fit for use. Otherwise, it is not. So again, it is performance specifications, not set basically figures and numbers that have to be met. Okay, so keep that in mind. Okay, so basically this is, I'm gonna stop here for now. This will be the end of lecture number 19. In order to keep the lectures, fairly short, I will stop here, and on the next lecture we will start on the first class of the admixture, which is the air entraining admixture. So thank you for watching, and I will see you next time.